Hi, back onto the repair for the Sony RX100 Mark IV camera. I've done two previous videos, so this is number 3. The TLDR is that, well, the camera's rooted. I kind of sorta fixed it in the first video by taking it all apart, putting it back together, and it seemed to work for like a day, and then came back the next day and it just didn't work again. So at the current state of this thing, I've taken it back apart. I've got a battery in there, which is good, and it doesn't, the power button just doesn't switch anything on. But if I plug in external battery pack here and I press that, it should come on orange. Yep, sometime later, so it flashes orange, but it only flashes the orange once when I press that. So I have no idea what that means. I don't have the screen plugged in, so maybe that's it. I don't know, but like I tried that before and it just didn't work. So anyway, leaving the screen off, that's that connector there because it's really annoying. Anyway, let's go into the schematic and let's have another crack at this thing, shall we? So I've got the schematic here. This is the power block. Well, this is the block system block diagram. There's a more detailed schematic further down, as we saw in the previous video. And if we have a look over here, here's our battery terminal. It's got positive and negative. It's got the sense wire. So that's battery temp. I don't, it's got nothing to do with that. Anyway, our battery unreg comes into here. So it goes through this flex board. And then it comes into system 1052 board, which I believe is like the main board that we're looking at. So it's got the processor, everything. You can see that like it's got a USB interface chip. It's got a DC to DC converter chip here. There's another chip there, IC8400 front panel control processor. And then we've got the IC6000, which is the big chip, which we saw on there like that. That's the big daddy there, which is not just these pins, it's across multiple sheets and everything. And as you can see, the unregulated battery, it goes into the USB interface. I don't, let's follow the money down here, shall we? It goes into the front processor, we don't care about. But then we do care about this. It goes into this voltage detection thing, Q. It's a transistor, given the designator Q. So a voltage detection and then a charge detection as well. So if there's something wrong in there, then yeah, you'd expect it not to boot up. At this time, we don't know. I have no clue why it came good and then didn't work again. I don't know. We could be chasing a red herring down a rabbit hole here. But hey, I want to at least try and measure the voltage on here, see if the voltage is getting from the battery to that board. So yeah, let's do that. So Q3001, so we can find that Q3001, ta-da, there it is. I love it. Search is good when these documents are searchable. They're fantastic. Otherwise, it's a real pain. So yeah, it looks like we have a couple of MOSFET jobbies here. And it doesn't go directly, this is battery unreg going in here. It doesn't go directly in, goes via 1 meg, and then over, this is Q3001 over here. So, all right, and X system reset. So I assume, nothing comes from, so I don't know, I haven't traced out the soft switch yet, which is the one on the top, the soft power button. Maybe I should do that. Now, there is a bat sense switch here. I don't know. See, there's so many things that you have to trace here. I can think of scenarios just off the top of my head where it could be any one of these different things. I could probably come up with half a dozen different scenarios that would cause it not to, not power on like this. But obviously, if we feed 5 volts into the board via the external USB, it at least the processor, there's voltage on the board, the processor, the soft power button, it's doing something, things like that. So, yeah, I mean, it could be something there. So we can find Q3000. Anyway, let's just find Q3001. Here we go. It's got the overlay. Beautiful. Sony, hats off. That is the bottom side of the board. Yeah, here's the top side. Here's the top side. Murphy, of course it's on the bottom side where I can't probe it. Of course. And we've seen how if you try and take this thing out of here, then the ribbon cables pop out and it's just, no. It's really horrid. I was hoping that would be on the top, but of course it's not. Anyway, maybe we can measure something else. Okay, what's IC 4302 in there? Like, you know, like, can we at least see that there's voltage getting on the board there? Bloody double-sided loads like this, and yeah, BGAs up the wazoo. Oops, sorry, I didn't show you that. Yeah, I had the wrong screen switched in. BGAs up the wazoo here, like BGA over here, over here, over here. Like, yeah, no, thanks. That's a real pain. And there's a giant one on the bottom as well. IC6000. There's IC9012, massive thing on the bottom. So that, wow, that is really a board and a half. I at least want to see if I can probe something on the top. That's what I'm looking for. I want to see that it gets from the battery through the contacts through at least onto this PCB. Otherwise, well, that's why it's not powering up. Right, so I'm going to rule out probing that transistor on the bottom. What about this thing on the top here? What about IC 4302? That looks like it does something important. Surrounded by all these inductories and these capacitors. IC 40, it's a PST 8623. Sounds like a little regulator jobby. And no, it's a reset. Actually, that looks pretty important, doesn't it? That's reg, unreg. That's the one coming from the battery, isn't it? Yes. Oh no, that's bat unreg. So bat unreg goes into here, and then reg unreg comes out of this USB interface chip. Oh, okay. So it could be like, yeah, okay. So reg unreg goes all the way over here to the DC to DC converter and over to here. There's also a fuse there. It wouldn't be that fuse because USB V bus is obviously coming in. No, now I'm thinking that's the like the USB accessory. No, because there's another USB power on down here. Oh God, see, there's like so many, and then you've got some diode OR in here for the X power on, and the X power on accessory. I assume AC is accessory, and then X USB power on, and I like. It's all over the shop. See how you can spend hours and hours, even when you got the full schematics like this. Yeah, like, and as I said, I could figure out a dozen different ways that this could fail. So you've got to, you know, you've got to pick your obvious ones first. Like things that you can measure easily, measure them. As simple as that. Thou shalt measure voltages unless they're hard. And then, yeah, measure the easy ones first. Aha! There we go. X power on. That's got to be. It's on off. It says on off. That's got to be. That is the tactile switch. Okay, so we know the tactile switch works. We know the LED under it works because that's like the power. It looks like, is that a dual LED? Yeah, it's, yeah, because they're similar proximity. So you know that those LEDs, it's probably like a bicolor thing. D, no, they've got separate Ds on them, but yeah, yeah, I think it does come up different colors or whatever. So that's the orange LED that we saw before. USB V-bus detect. So it was obvious. So when we press the button, it after a couple, like 3 or 4 seconds or something, then that LED came on, right? So we know that all this flex board here is all okay because this switch goes over to X power on. So if we copy and find that, right? X power on. Well, yeah, okay. So it goes through and then S001. What's S001 and a depression? I have to think about that a bit more. Where else does it go? Yeah, it goes down here. Oh, X power on Piro, X power on 1, X power on blah, blah, blah. No, we could probably put a space after that to search for just X power on because there's X power ons with lots of numbers after them. X power on. Here it is. Yeah. All right. So that comes through that little diode or jobby there. Okay. And then we've got a link here and that becomes X power on PIRO. Whatever that is, power, I don't know. So the switch comes on, it pulls that Schottky diode low, and then you can also do that with the X power accessory. That makes sense. Okay, so if either of those go low, it switches the camera on. So you can remotely switch it on via the external, and then it becomes this. Okay, so we could search for C3004. I mean, if that's on the top, right? If that's on the top, we can find that. Except there's another one. Oh no, that's on the, no, okay, so this is the real schematic. The other, as I said, was the like a block diagram kind of thing. Oh, it's not gonna, oh, there it is right up the top there. That's on, not, no, that's on a different board. That's on the bottom board. That's the SD card board. That's useless for us. That's even more inaccessible than the bottom side of that top board there. So no, screw that. All right, so we're back to here again, are we? So we've got to follow the money here, and then of course this will all be fine. Murphy will guarantee that all this is fine. Right, so that goes, Pyro becomes, that becomes, so X power on Pyro becomes X power on 1. Oh, come on. Give me a break. Really? Okay. So X power on 1. How did anyone make heads or tails designing this? Wow, really? X power on 1. Okay, that goes front panel audio processor. No, we don't give a rat's about that. There it is again. Okay, so yep. All right, yes, okay. The block diagram showed that better, so we just wasted all our time. Should have believed the block diagram. So, yeah, okay, where's that? Is there any capacitor? No, that's it. No, okay, well that's, no, that just takes us to the front. No, like I said, Murphy guaranteed that was a red herring. I don't know, well, is this 5650? Is this findable? Can we do this? Because maybe, oh, it's on the bottom side. No, I see it right down in the corner down there. Yeah, it's on the bottom side. Yeah, no, that's no good either. Be interesting to know what the bat sense switch is. Like, I didn't know that it detected that the battery was, like, it had a switch that detected whether or not it's in. So bat sense switch becomes unreg mon, which then goes into, yeah, the audio processor. What's the audio processor? That's the second time we've seen the audio processor, isn't it? Well, what's the deal with the audio processor? Just from a system design point of view, why would an audio processor, like, be involved? Front panel, oh no, front control, okay. No, so it's front control and an audio processor. They've combined it. There you go. That's why. Okay, and yes, and here it is. It takes bat unreg, reg unreg, bat sense switch. It's got everything. Backup VDD, regulator ground. It's got the whole shebang. Wow. Okay. So IC8400. So where's that? And it's on the bottom. Of course, it's on the bottom. Yep, it's on the bottom. See, what's things like, you know, this reset here, right? And X-Wake and stuff like that. Like, that, that sounds kind of sort of important, doesn't it? Oh, that's the one on the top. There you go. It's that one right down there. There you go. So, maybe if we start probing around that area, it's gotten to the point where, yeah, let's just start probing, because this is boring. Trying to follow the money here. It's just change the auto range there. Let's just fix it to 10 volts so we just don't have to dig around with auto ranging, because auto ranging can be a bit of a dick around. You can waste your time doing it. There you go, 4.26 volts. That sounds an awful lot like the battery voltage, doesn't it? Or battery, or 5 volts minus the diode drop, right? So there's voltage on that board. There you go. All right, well, what I'm going to do, disconnect that. So there's now no external power. I still don't even know what point I was probing there, which pin. I didn't even bother to check. I just started randomly probing. But, of course, you expect voltage on the board when there's 5 volt USB coming in. 3.9. Ta-da! Winner, winner, chicken dinner. See? Random probing around helps. So there's definitely voltage coming onto the board. 3.9. So I know I measured the voltage before. Yeah, it was like 4.15 or something, 4.2. It was, you know, it's a fresh battery. It's a reasonably fully charged battery. So, yeah. So we're getting voltage onto the board. No problems whatsoever, okay? So the battery's all connected. Everything's hunky-dory. But that transistory, Sony are so nice. They've even put, look, drain, gate, source on the overlay. Oh, this is designed for servicing. They've, you know, they went out of their way to do that. That is great. So you didn't have to look up the data sheet of the chip or know what it is or whatever. It's just, yeah, there was the drain. Okay, there's the gate. That's absolutely fantastic. See, but the problem with this fault is that it worked. Like we had the exact same fault as we've got now. It wouldn't power it on. We took it apart, we put it back together, and it worked again. It worked for like a day. You saw it. So this is not like, oh yeah, okay, we've blown a tranny in here or something, right? It's not that. You know, something's like, because that is the least likely scenario that a part's blowing. So I wouldn't go suspecting parts willy-nilly. Like, there was something in the process of taking it apart and putting it back together that made it reset. And of course, we speculated that in the previous video about the backup battery and stuff like that, causing that sort of problem. But I guess, like, can we measure the backup battery? I don't think so, because it's right down on one of those flexes in there. We'd have to take it all apart again. But there's definitely voltage getting to the board from that battery. So, yeah. And I find it hard. I think it's unlikely that a component is just blown like that, because otherwise we wouldn't have been able to get it working by putting it back together. It worked fine. And we know why the screen scrolling thing happened. That was, you know, an open pin on the LCD connector when I put it back. Or, you know, some dirt or some other grubby thing on there, making bad contact. It was floating. Yeah, so the last thing I'd do would be sucking parts off here. You just, no. Something, there's something trickier. There's something trickier to this. And it's annoying. Because it'd be relatively straightforward to troubleshoot this if you can access this. But the physical part about this is that, yeah, just the way it's assembled and everything, and it just makes it really difficult. But we know it's getting onto the board, so, oh boy. So Q4301, so we do know that much. Okay, so that's a switch after your VDD out reset thing. So we know that's getting the voltage, right? We know that's getting the business. So let's go and have a look, right? There's the source. The drain is down here. So X-Wake is the one that had the voltage on it, okay? And then to drive that, it has to be driven by this reset switch here. So this symbol here shows that reg, unreg comes in. This is an in arrow, that way, right? So that comes into here, the source, this transistor must be turned on because we're getting X-Wake here, we're getting the voltage. So reg, unreg, you'll find that the source and the drain would be the same voltage. I mean, we can probe that. All right, I'm going for a finer probe this time, one of these fluke jobbies with the spring-loaded thing. So let's go in here, let's remeasure that. 3.93, no wuckers. 4.13. It's not, there's some drop on that. And our gate, 3.76. Right, so there you go. That makes sense when we're measuring the gate. Okay, so we're getting our reg, unreg in here, and then we were measuring the gate voltage here, right? But that's because our 10 meg ohm input we were reading under, because you get the voltage drop between the 1 meg gate source resistor here and the gate. So yeah, no, that needs to go to ground to switch on that MOSFET. And the reason that we got the voltage over here, I don't know, but it was lower, which means that, you know, if the transistor was, well, it's obviously not switched on, but if it was switched on, X-Wake would be pretty darn close to X-Reg, whereas it was, yeah, with 3.7 or whatever. So that's not it. But still, I don't even know if I'm chasing the right thing. I'm not sure if that's supposed to be on or not, or when this reset thing happens. All I can do is try and probe this at the same time as trying to switch it on. So I need my 3 hands. The problem is the power button moves the whole damn thing. Yeah, it changes just a little smidge when I push the button. It does something. But yeah, it's not, obviously not switching that on. So that's, you know, yeah, it's got nothing to do with it really. I don't know. I'm just probing stuff because I can. This is sad. Right, so maybe I can measure the lithium battery in situ. So let's give this a go. BT900 lithium battery backup VDD. That makes sense. Let's try backup VDD. Maybe if if the battery's dead and backup VDD is not there, it doesn't power up. Maybe if the battery dies, it does not power up. And why it came good that day, I don't know. It charged itself. I don't know. Because it's not rechargeable. I don't think it's a rechargeable jobby. I think it's just a primary. Backup VDD. Here we go. Backup VDD. Ever VDD. I mean, how many VDDs and other crap have we got in here? It's unbelievable. Once again, it's this audio processor chippy, right? That's front control and audio, well, front control processor, right? Backup VDD, it goes directly. What's an ever VDD? It's ever, it's always on, it's forever on. Anyway, D5100. So one end of D5100 we can measure. What are the odds it's going to be on the top of the board? Bottom of the board. It's bottom. Of course it's the bottom of the bloody board. I can't see it in there, but of course it is. There it is. D5100 right there. Oh, where else does it go? This capacitor here. Something, there's got to be a via in there which then pops to the top side. These aren't mirror image, are they? Oh, is the program locked up? I think the program's locked up. I'm using the Edge browser. I don't normally use Edge, it's just because it's like for screen, I only do it for like screen captures and stuff. Oh geez, come on. No, the whole document's gone. Trying to measure ever VDD, that's not going to help us because only if the diode was in the other direction. So that's not going to help us at all. Backup VDD needs to come across here. Like, I don't want to have to take the thing apart. It's such a pain in the ass. Don't want to have to take it apart and physically try and get access to the battery or the ribbon cable for that thing. So I'm trying to do it on the board, and I'm probably a glutton for punishment. It doesn't. That schematic's wrong. Backup VDD, right? There, goes into the diode. But goes into the cathode of the diode, but the other one didn't show that, right? It shows that it also goes into the chip, but it doesn't. Look, backup VDD also goes into IC8400, and according to the actual schematic, oh, it does not, right? That means it goes in, no. That's, it should, this shows the IC. It doesn't show the sheet for the IC. It's not like it's going into the page, right? It shows it going into that processor, and it doesn't. According to the actual schematic, it goes nowhere. So that doesn't make sense. That does not make sense at all. Why would a backup battery go into a reversed biased diode like that? That makes no sense. Now, it makes sense that this ever VDD would then diode, or no, even that doesn't make sense. Because if that powers through there like that, then it's going to charge the battery, and I don't think it's a rechargeable jobby. There's no other info on it. There's no part number or anything like that, but it's got to be a primary. And that schematic makes no sense. Aha, backup VDD also goes through R101, a 220 ohm jobby. Right, that's interesting, right? So backup VDD, yeah, we've seen that. Oh, okay, C84, there you go, C8414. Okay, so C8414, that RTC ground, real-time clock, because that's what the backup battery's for, basically, is like the real-time clock. So Yeah, so if we can measure across C8414, which of course will be on the bottom of the board, of course it will. Anyway, or we can measure, yeah, we've already looked for, yes, 8414, yes, we have looked at that before, haven't we? Yes, 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 we have. So R0101, come on, come on. No, it's on the bottom, of course it's on the bottom. Oh, that makes sense. That is the secret ribbon cable, isn't it? That's the secret ribbon cable. Okay, yeah. Okay, that the the power ribbon plugs into, right? Yes, that's the power ribbon cable, and yes, the temperature sensor, that's right. So they have like the 3 or 4 pins or whatever each side, and then they have the temp sensor which goes up here. Okay, so pin 1 over there, and it's all on the bottom. It's all on the bottom. Of course it's all on the bottom. Unbelievable. It goes into that diode, goes into there, right? But once again, I'm not seeing how that makes sense, because that's reverse bias. You've got positive coming out of the battery here, okay? And then it goes into R0101, fair enough. But then it goes into the cathode of D5100. That does not make sense. Am I wrong? There's and then there's the capacitor to ground, right? And then after that, on the anode, there's the capacitor to ground. That doesn't make sense. That's not how that's not how a backup battery works. A backup battery it'll go into the anode of the diode, so it's forward biased, so unless that battery's back to front. Hang on. Let's check the polarity of the battery. My stupid bloody browser's locked up again. No, it's showing the positive there of the battery, right? Yeah, once again, how does that make sense? How does that make sense? Backup no, okay. No, yeah, like, it only makes sense if it actually goes into a pin of the processor, but we know that's not the case. There we go, okay. No, okay, so the diode makes sense because backup VDD does actually, doesn't go through that diode. Okay, right. But then why is the diode there? Why is that diode steering there? If, you know, is it to charge up the backup? Like why would there not be another diode, a reverse protection diode a series diode on the battery? Doesn't make sense. All right, the only thing left to do, I really need to check that. I think it's important that I check that backup battery. So the only thing I can do is to flip this board out, try and not dislodge any of the cables, and I'll get, like it doesn't, yeah, I'll get back to you. Flip those bars. Okay, carefully. Probably should just take the battery out as a matter of course. Okay. Here we go. So one screw in there. Oh, I forgot about the ribbon on the bottom. Oh, that's killing me. All right. So yeah, I'm gonna have to disconnect this one, flip it up, disconnect the other one, then reconnect this. I flipped all that out. Let's put this back in here, and I can access the bottom. So enough dicking around on the top. We know we can't do much on the top due to Murphy. Slide that sucker back in there. And, okay, she's in. All right, now we can successfully flip this board out and now access the bottom. The thing is, yeah, we have to keep that one because I've already taped that from last time. Of course, here's our power, so we can measure our backup battery now. That wasn't too hard. Should have done that before. Should have just bit the bullet. There you go. There's our components we're looking at. There's the diode E, and there's the resistor, and there's the trace coming in. So now we should be able to measure that. Wow, nothing. Nothing. Yeah, that battery's dead. That battery's dead. Is it that easy? Is it that easy? Is that the correct ground though? Because there was the RTC ground, wasn't there? And that could be different. The RTC ground could be different. but I know I'd expect it's not floating. It's got to be referenced somewhere. What if we plug our battery in? Ta-da! There you go. We plug our battery in. We get our 3 volts. Ah, hang on. That's suspiciously the voltage of a lithium coin cell. Ah, 3.1. Okay. Right. So nothing activates until we get the... What? Huh? Ah, maybe it's that switch. You remember that we said there was like some battery switch or something? That maybe, yeah, if you don't insert the... But no, why would the backup battery die? I don't understand why the backup battery would be disconnected from if you take out the main battery. That doesn't make sense. Yeah, sure enough, with the battery out, we get diddly squat. So I'll push the battery back in, and ta-da! That seems like a backup battery voltage to me, doesn't it? So it looks like that lithium backup battery is gonski, because when you take out the battery like this, there's nothing there on that resistor, which then feeds into that diode, and then it also goes off to that chip as well. So, and the 3 volts being pretty much what you'd expect from a lithium battery, that was actually coming from the diode there from this battery here. So that's like it only dropped like 0.1 volts or something, you know, because there was no load on it, and it was like a silicon, it was a shocky jobby, and yeah, so it's, there you go, the backup battery. So where the hell is it hidden? It's in a ribbon down there somewhere. So based on the schematic, it does actually seem to be like a rechargeable battery. So because it's got the diode, which then back feeds it in there through that, what was it, 220 ohm resistor or something like that. So it's gone. So like I can maybe understand why we took it apart, put it back together, and then it suddenly worked for a little while. Maybe the battery was like accepting some charge, and now it's like got nothing on it. I don't know. We need to actually... Problem is, we now have to take the boards out and get back in there and get access to the battery. And of course, I'm not going to have like a replacement for it. So, I don't know. Can we like temporarily... Maybe we can like temporarily bodge something in and see if it like powers up, if it has that battery source there. I mean, it's very poor design that it doesn't power up with that backup battery. It should power up and just lose the contents. That should be it. It should stop the camera working. That's really poor. But yeah, at least we've got something to work with now. The battery's gone. That seems obvious, doesn't it? Yeah, so it's all going to have to come out again. I really should have, like, that's something I really should have spotted on the first teardown. But as you saw, like I did not see at all the backup battery in the first teardown at all. It just, I don't know, I don't even think I saw it on the when I watched it again. Yeah, so it's in there somewhere. So let's get all this out again. Is that it there? That's our battery. There you go. I see something round. I see something round and battery-like. There you go. That's got to be it, right? No wonder we didn't see it, because it's like kind of like, yeah, it's taped in there, right? That is taped in there. So we should be able to access that, actually. Can I get like a scalpel in there? And can I, that's just like taped in. There we go. Is that it? Yeah, I think that was, yeah, that was just glued down or something. There it is. Got him. That's a welded tab jobby, and it's soldered down in place. Indonesia, huh? Anyway, we can actually get now directly on there and probe that sucker. And I think you'll find that she is gonski. Yeah, there you go. So I like, come on, it's got to be it. It's sort of that's the only really thing like, that explains why it would, like, maybe, like, come good, like, once, you know, for, like, a period of hours and then just die completely. The battery still had, you know, it was taking its last gasps or something. So anyway, let's desolder that sucker. And this is interesting. Look, it's bounced back. It's coming back. It's rejuvenating itself. What? We measured, we probed that, and we were getting enough oil. So I don't know. It's maybe, like, is there something else gone in there that's loading it down? Don't know what the deal is. I'm just going to solder that back on. It's not close, but it's good enough. I don't think it's shorted. There you go. We've still got some voltage on that. So it's, yeah, it's recovering, because I'll shorten that. I'll shorten the poor bastard out when I was putting it back in. But let's put the battery in there. Yeah, 2.47. I don't know why we were getting nothing before. So that's going to slowly charge that sucker. I'm actually going to try and switch this on just for kicks. I mean, it's got absolutely nothing plugged into it. No, it doesn't like that, does it? So that's slowly creeping up there. I don't think that's charging from the battery. I think that's just electrochemistry recovering. Anyway, the point is, it does seem to be retaining a charge there. So what's going on? So if we follow the money here, RTC ground becomes reg ground, okay? So backup VDD is the thing that we want to actually follow the money on. But just remember reg ground. Here, yeah, we know about that. Here it is, here. And it goes over to the battery, and it shows the battery actually going to, that's like chassis. That's like, you know, chassis ground kind of thing. So BT900, if we zoom in on that, there's our lithium battery. Oh, it doesn't actually tell you, right? It must be connected through, like, the chassis ground must be the battery ground, right? Because there's only one, like, there's no extra wire on there, is there? So BT2114, and yet, sure enough, the negative of the battery is connected through to the battery, the lithium battery that powers the camera. That's it, straight onto the terminal. Straight there, and that just goes through to pin 1 like that. And we know that that is a rechargeable jobby through that 220 ohm resistor. There's silly buggers at play there. 2.56788. Yep. And that is recovering due to the chemistry. And if we plug that in, it's not actually charging up any quicker. So our battery is not charging when you plug in that, and it's supposed to, and it's not supposed to do it when it's switched on. It's supposed to do it when it's switched off, right? So I reckon if we follow the money back on that, I don't know, we might find something. Is that it? It's not the battery at fault. It looks like that maybe the charging for the battery, but it's basically through that diode, isn't it? Here it is there, backup VDD, that's that pin 1, so that's coming from the flex. So the flex goes into that 220 ohm resistor there. Can we measure that 220 ohm? I can't see how the 220 ohms gone, Ski, but you never know, you're lucky in the big city. Let's get back in there with 2 smaller probes. I'm going to stick with my, yeah, there we go. Yeah, no worries, so that's no problem. There you go. So the diode's okay. The resistor's okay. That resistor's not playing silly buggers, is it? So that would be charging up the battery, and the battery's over there at 3.03. So, okay, 3.03. And if I disconnect the battery and measure it fairly straight away, we got nothing. Why do we suddenly get nothing on our battery? Why? What the heck's going on there? Am I not making contact? Pretty sure I'm making contact. There's nothing. on that battery. Am I remembering that incorrectly? There's something 2.59 volts. What? What's going on? What? Why can't I? It's making an absolute fool out of me. And we know it's connected through to, right? It's connected across one of the ground pins and then to the 220 ohm resistor there. One side of it. It doesn't matter which side of it you measure. We know it's okay. Is this just not in? It's in as far as it goes. It doesn't go in any further than that. I have access to the pins, which there you go, is measuring 2.6. There's 2.6 volts there. There's nothing. This is the temp thing, right? That's the temp pin. We knew it was pin 1. Was the one ground next? Was the ground next to it? It's not this one over here. There's no voltage. There you go. That's got to be it, right? That's got to be it. Is it something to do? Is the ribbon busted? Let's go to the continuity. Nothing. Positive of the battery. Nothing. What's going on? They're both busted? What? Negative. Goes to this pad here, right? Yeah, which is the one next to it. Which is the one next to pin 1. There, so pin 2, 3, and 4. And then the positive of the battery is supposed to go through the flex down to here. Neither of them have continuity. What the? Let's get physical. Physical. I want to get physical. Okay, that's the positive. That's the negative. There's no negative. What the? How can the negative not be there? Like, that's a massive trace. That cannot be broken. Oh, well, actually, no. It's only small going from the battery. There's the traces running down in there. Is it? Oh, hang on. Hey. Hello. Oh, yeah, look. Yeah. Oh, the whole thing's broken. The whole thing's broken. Yep. Yep, okay, it's still sticking there. You can see it. Oh, wow, okay. No wonder, look. Yeah, look, it's entirely cracked. Wow. Now, I wonder if that happened during my brutal teardown, but, like, assuming that this is actually the fault, right? Assuming that this is the problem stopping it booting up, then, it must have happened before I tore it down, right? Maybe because this was bent over on a very hard radius, like a 90-degree radius. Maybe it just cracked due to, like, material fatigue or something. Because it doesn't, this part, like, it's not like it flexes. Well, I guess there's a bit of, when you put the battery in, like, there's some like, pressure on that whole assembly. Like, there is, yeah, actually, there is pressure on that whole assembly. Every time you push the battery in, right? So that whole assembly moves. Okay, so, yeah, okay. There's some strain on that flat flex. Maybe it's just broken. But there it is. Yeah, I was wondering how, you know, like, there it is. You can see it cracked. Oh, you little bastard. Okay, come on. It's got to be it. Right, surely Murphy's had enough with me. That's got to be, he's tortured me enough, bloody Murphy, right? And there has to be, that's got to be it. That's got to be stopping that powering up. Is that's not a copper return? No, because we've already measured that power gets to the board. Okay, so it's only the, we can go back to our videotape. Look at them all. I love just looking at flex boards. They're just absolutely fantastic. Anyway, here it is, right? Yeah. So it obviously, like the battery, yeah, the ground doesn't go up there. The ground doesn't go up there. But that part right there, right across there, both tracks, that's the point it failed. Probably because there's probably more stress on the outer part. I don't know. Mechanical engineers tell us, like when that cable flexes over like that, when that battery folds over and upside down into there, there's a 90-degree bend on that, And then if you got the whole assembly going wiggle, 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 yeah, in there, each time you take out the battery, is there more stress on the outer part or the inner part? But anyway, the outer part is broken. It's just sheared, like half of it. It's just sheared across. Both tracks. Gonski. So therefore, the... only took me like an hour and a half to find this, right? With careful view or a careful inspection or just lucky inspection, I could have found this. The first time I took it apart, I could have found it in 10 minutes and, you know, boom, right, oh, problem, let's fix that. Does that fix the problem? I'm assuming this is going to fix the problem. I'm assuming it's not booted up because there's no battery there, right? So, yeah, it's just coming to guts completely. That's interesting, huh? You bastard. Look at it. Look at it. Here we go. Here's some fail porn. There you go. Demonetized. You can see both the traces under there coming out. Jeez. Wow. Look at that. So, how do I fix a flat flex like this? Well, unfortunately, so the traces are on this side, so that makes it a bit harder to access in situ. There you go. Yeah, it's just I couldn't think of a more inconvenient spot for there to be a fail to try and repair that. That is, and it's right on the bend too. So, and it's on the underside of the bend. I can't, Murphy again, I couldn't believe, like, it couldn't possibly be in a worse location for that to happen. That's just terrible, Muriel. As a bodge, if you were really desperate, you could run wires direct from there up to the bottom of the main board. But once again, you've come a gutser because you've got to go to the bottom. You've got to solder onto the bottom of the main board right in here. But you could, right? You could, like, if you thought that you could tuck the wires away and stuff like that. But even if you use really fine mod wire, this fit to envelope design is really tight. So I don't, yeah, you're probably not gonna do that easily. Oh, yeah, got it. That's right, it was taped down. That's right, I remember. Need to watch my own video, it was taped down. All right, so no wuckers. We can get in there, and we can of course now zoomy right in there. I can see that brake. That's terrible, Muriel. Ta-da! What a mongrel, huh? What an absolute mongrel. Both traces broken. Wow. Right, how do I actually get that off? It's got like a copper thing on the back. It's got a whole copper clip going over. Maybe I get that tape off. That black stuff looks like tape holding it in. Oh no, there's a screw. There's one screw. All right, I'll take that out. I'll love how they use practically almost all the same screws in this thing. Well, that didn't do anything. Complex little assembly in its own right. I mean, that's you know, just that whole battery system is just crazy complex. The door and the hinges and the flat flex and the way, you know, the battery holder, and then this thing on the side, which I don't know what the heck's that's doing. That big metal, like, it's almost like that's a little die-cast metal bit, and what's all this? Copper on the back. It's a hugely complex thing. I can't believe that they didn't have a team that went through and just optimized, you know, optimized assembly and stuff. No wonder this is an expensive camera. Imagine trying to assemble this and all the different parts required. Wow. Starting to think all this stuff in here is bonded. Like, I took the tape off the back. Nothing's coming off. Everything seems like, I don't know, at least adhesive bonded in there. It seems really annoying. I'm like, you know, I can get into these, but there's not enough purchase down there to sort of, maybe I could try and do a fine wire link over, but oh man, it's going to be ugly. Can chop out some of the plastic there, maybe. Don't need the plastic. Chop it out. No worries. And they're so close together. The pitch is just incredibly small there. In fact, I can tell you what the pitch is. It's hard getting both of those in there, but there you go. That's 0.1 millimeters. Sorry, 0.01 millimeters. That's 1 millimeter. So there's 10 divisions in there. Look at that. Like, yeah, the pin pitch is naff all. Trace pitch, sorry, is naff all. So yeah, that's not fun. I almost think it's going to be easier to simply put some tiny mod wires. I know it's a horrible bodge, but I think it's actually going to be easier to put like some mod wires just from here and just solder it onto the main flex here. See, the problem is, like, just scraping off the polyamide coating on the traces there is going to be difficult. It's not something you can easily do. Like, technically I can get an iron down in there, but they're so bloody close together. Like, just even scraping that flat flex, you're not going to be able to do anything. So it's really tolerant, robust stuff, except when it breaks like that, when it turns brittle and just breaks. Yeah, I don't like my chances of even like putting like links back on there. It's just doesn't really seem doable. Put mod wires over there, over to this ribbon, and once again I got the same problem scraping away the ribbon, but at least I have more chance here. You know, even if I've got room to get down, I probably do in theory. I've got room to get down there and scrape off the polyamide coating on top of the traces there. But even if I did that, I'd have to put little tiny links in there. How are they going to stand up to the flexing? I don't know. But anyway, trying to scrape off, you really have to like do a physical abrasion type thing with a scalpel or whatnot. But I've got no physical backing to do that on, really. Like, it's awful. At least this big one over here, right? I can at least put something hard under there and then get on there with the scalpel and try and scrape it off. So I'm going to give that a go. So I'll get that on a surface there. It's just awful job trying to do this. Imagine if you had to repair a multi-fine pitch thing. It's just, it's really awful stuff. For those who think you can do it with a soldering iron, got very little luck as well. See if the Swiss Army knife is... Am I through to the copper? Oh yeah, I'm through. It looked like it went all the way through. I think I'm through. I think I scraped away. Depends on the type of knife you have. My Swiss Army knife just seems to be better at that. That's the gold surface, right? Yeah, it is. You have to get in a certain light. Okay. See if I can do the same thing. Okay, yep, I've exposed some of that. So I've exposed both of that. Now I can maybe get a fine pitch iron in there. First thing you're going to want to do, put some fluxy on it. Okay, I'm going to tape this in place. There we go, we got some take onto that. Nice, okay. Flux pen. Even though there is flux in my, believe it or not, there's 5 cores in this 0.38 0.38 millimeter solder. There's apparently 5 cores of flux in it, I think. Yeah, 5 cores of flux. How the hell do they get in there? The Oompa Loompas at the flux at the solder factory. I don't know. Magic. There we go. Beautiful. Thing of beauty. Joy forever. Look at that. Bobby Dazzler. All right, mod wire. Beautiful little mod. Look at that. Now, whether or not these wires are going to fit, you can cover that with insulation if there's anything conductive on top. Got to watch for the metal case and everything like that. You've got to be careful you don't come a gutser there. But we can cover that with some insulation. So what I want to do, so now I can solder that directly over now. But now it's a matter of like form fitting the wires. Like, actually, probably can't do that until it's all reassembled and I kind of sort of know how much like play I've got and stuff like that. So it's not, yeah, like how to form the wires. So you're better off like figuring out how the wires form first in there, and then cutting and stripping them and soldering onto the battery, I think. So yeah, anyway, so this one here, I know they've got the same color. Probably should have used different colors, doesn't matter. So yeah, but this one's obviously, of course, that's our battery positive. So that goes to the case over here, which is our left-hand pin over there. So yeah, I mean, I could fold it back in, but then where does the SD card board go in relation to this? I can't remember. It screws on there. I don't know. I'm tempted. Right, I think I'll put this back in the camera now, and I will attempt sort of partial reassembly just to see where I'm at with, like, in regard to how I can form these leads. Right, so that goes in there. SD card board is the biggie. I probably should have had the wires coming out the other direction rather than out the bottom, the top like that. So it looks like, right, we can probably form the wires down through here and around and over, under, like that, over, under kind of thing, and off to the side of the board, because the board's going to be in there like that, and then we should have enough gap to pop them out there, I think. So something like that. Ugh. But, you know, here's where if you cut it wrong, like you've just, you know, you kind of have to like start again from scratch. So that's really rather annoying. And yeah, I shouldn't have put those on the coming out the bottom like that maybe. And this is the smallest mod wire I can got. I can go smaller. If you want smaller mod wire, you can, you know, get a multi-stranded cable and you can strip it and get little individual strands out of there, and that's a good way to get yourself some mod wire. But of course it's not insulated, doesn't have the yeah, this is the smallest insulated mod wire I've got. For those playing along at home, it's 30 AWG OK Industry wire. That's just like my standard mod wire. I think I'm gonna have to just hold my tongue at the right angle and guess that. Now of course when you strip these, you want to hold on to them. Jeez, I hope all this works. I hope all this effort's not for zip. That would suck, wouldn't it? Okay, we've tinned those. Okay, let's go for broke. So we've done our little mod. Now we've got to flip our battery back down into its little holder. Yeah, I think I cut them too short, damn it. Maybe. Has that actually gone down flat? I don't know. A ribbon I've had problem with in the past. And I've broken one of them. Yeah, I've broken one of them. Yeah. Okay. Yeah, so I soldered that down too far. Yeah, I didn't account for the coming over the top. Yeah, I had to simply I'm going to have to desolder that. No, I'm going to have to do it again. So that fitted back down. I've got that fitted back down. And I've got the wires coming out. I'll screw that board back in, I think. Here we go. So that board's back in. I've got two wires coming out that are probably not going to be long enough now. Tell you what, I'm going to worry about all that later. I'm just going to... no, because this goes on the underside of the board, doesn't it? Goes on the underside of the board. Goes on the underside of the flippy like this. So it connects in like that. So... yeah, oh man, this is nutso. Yeah, I needed finer mod wire and I should have made it longer. That was dumb. I should have soldered them onto the battery, fitted the battery first, had the wires coming out, and then once they were out, I should have put everything back together and then cut to size and then figure out where to do the scrape. But then you've got to have a hard surface to scrape it against. So, you know, like, but here I've conveniently got the board. Yeah, I should have done that. That was dumb. Now, regretting that. All right, that was obvious with hindsight. 2.46. Okay, so that bottom one is negative. So I'll just mark that so I don't goof that up. Maybe it's just long enough. Maybe. Now... the problem is, when I fold this like this, it comes back like, no, they're definitely not long enough. Right, when it folds over like that. I mean, you know, look, there's no reason why I couldn't, like, solder, like, the ground down to, like, here or something like that. Like, there's no reason why you can't take, like, a shortcut like that, for example. because it's only battery, it doesn't matter. But to test that, I've got to put the ribbon cables back in and test the continuity. I think I've taken some trace off there too. All right, so what I'm going to do, yeah, I'm just going to have to scrape some more off. There's my teeniest, tiniest heat shrink. We'll give that a go. Couldn't be bothered using the hot air gun. Soldering iron's good enough for Australia. Adds a bit more bulk, but nah, she'll be right. We'll stuff those wires somewhere. Okay, so I've got those wires attached. I reckon that can stay. Oh, yeah, that one's a bit how you do it. Anyway, well, we'll see. We'll see. Let me see if I can get this back together. And, yeah, see what we can do. All right, so this has to go under here first, I think. So that's our battery. It's a real pain in the ass connector, let me tell you. Now the battery connector, this is ridiculous. Be careful, this is the one I soldered to. So it's getting flexed to buggery. Then you got the top panel connector. And this is just, really is crazy stuff. You get used to this, I guess, if you're doing it every day. But that's not all the way in, is it? So as you can see, I've soldered a 220 ohm resistor onto there like that, onto that diode, and I'm hoping that does the business. That's the plan. Anyway, so fingers crossed. I've got to anchor down that wire because as I like move, you know, flex and move this board back into position and stuff like that, it's just going to completely come a gutser. So I really need to stick that down. So probably some super glue or something. Something needs to stick on there somehow. Okay, it's back together. I think. Let's put a battery in and let's see what happens. Okay, press the power button. Nothing. Hold it down. Nothing. Although it might need time to recharge the rechargeable battery. Assuming it's all still connected. Let me plug in the USB. Wah, 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 wah. Doesn't work. After all that work. Zippity-doo-dah. Did I forget something? Don't think so. I just cannot cop a break, can I? So, unfortunately, it's, like I said, it's difficult to, like, measure things in here after you've reassembled. You just got to reassemble it and hope that you've done the right stuff and it's worked. But in this case, nope. We've come a gutser and nothing happens again. I don't even get the orange LED anymore, right? From the USB. So I don't know what's going on. I'll measure that USB current actually. There you go. It's actually drawing 1.4 milliamps. So if I press the button, does it do anything? If I hold the button down, does it do anything? Nope. Does absolutely nothing. So that could be trickle charging the battery, could it? Or that's just other standby stuff happening in there, really. Is that, and yep, that's genuine. Oh, there we go. So when I plug it in, it draws 150. I presume that's like charging the battery. It realizes, oh no, battery's pretty full, and it switches off. That's another hour at least down the drain. Well, not down the drain because we did find a fault on this thing and I did my best to repair it and put it back together, and it's doing nothing now. So almost back to square one of trying to get all this stuff out while leaving it connected and then measuring voltages, and that's it. I'm done for the day. My time has run out. I'm gonna go home, so that's it. Give me a big pity thumbs up. Whilst I connected this over to here, I can't see a trace going off from there to the IC, which is the direct backup, because it doesn't go through the reverse bias diode, right? So I'm thinking that there is a via down in pin 1 there. So pin 1 is isolated. So I've got to short out that 220 ohm there. So that might kick it back into action. That's what I'm thinking anyway. Okay, what I'm going to do now is I'm going to look across, we'll measure the voltage across C8414, because this is supposed to be the capacitor that is across VDD backup, like actually on that backup VDD pin D3 there. So if you're not getting voltage on there, that's what I suspect is not causing it to boot up. So if we can measure the voltage across C8414, then we can verify whether or not voltage is getting there. I have actually measured voltage on the board. I am actually getting my 2.9 volts or whatever. It is on the board. So that part of it's working. So I need to peel back some of this thermal pad to reveal the capacitor down in here somewhere. Once again, the problem here is that I can't probe on the underside of here without plugging in the actual connector, because that's where the battery voltage comes from. I just don't have the flat flex length. Here's the flat flex. We've got to connect it over to here. So that's really annoying, because the capacitor I want to measure is that one down in that tiny little bugger down in there. And that is the input pin to the micro down here that detects the backup battery voltage. So, and I can't measure it in situ unless the board's flipped over, and I have actually measured that I am getting the voltage on here at the end of the resistor, but whether or not it's coming over to that pin. So all I can do really is I can try and measure, actually, I'll measure the continuity there. Okay, the only thing I can really do now is short out those two pads in there, join this back. That's pretty much all I can do. So I'll give that a whirl. It's really hard it's so hard to get in there with the iron. It's crazy hard. And then trying to support the board as well. You can see the board support I'm using. I've got a PCB-ite, none of that PC byte. Put a hyphen in the right place. And yeah, and then then the camera's propped up on the multimeter here, and it's just, yeah, it's nuts. It's nuts. Anyway, yeah, this is what you have to do, because I don't want to have to keep taking the board out every single time I want to do work on it. It's just, yeah, it's crazy. And then when it's in, you just can't probe anything. It's nuts. Oh, did I get it? I think I got it. I think I got it. I think I bridged that. It's a bit how you doing, but I think I might have got it. I don't know. I'll just try it. Let's see if I can buzz that. Shall we? Yes. Got it. All right. I'll flip it back, plug it all back together, and see if it does anything. The super glue, by the way, on my wire in there worked really nicely to glue that in place. And so that's all solid. So I can flip the board in and out. And the other wire down in here is holding on really well, because it's connected through to that big, fat, meaty ground trace running through there. So yeah, no worries. So I can sort of like handle the board now. So it's really quite okay now. So let me put it all back together. I'll get back to you. All right. It's in. Let's see if I can do anything with it. Again, wah. Nope. Let's plug in our cable. Though I don't have everything plugged back in at the moment. I don't have the SD card. So that could be a thing. Hey, that's actually holding more charge than it did before. For longer. It actually dissipated to 0. That is progress. That is progress, because when I plugged in the USB before, it was it initially surged to like 150, 180 milliamps or something, and then within seconds, it sort of dropped down, like 5 seconds, it dropped down to like 1 milliamp standby. So obviously, it's charging the battery at the moment. So that's interesting. So like I don't have the LCD plugged in, I don't have the SD card plugged in. Okay, so I'm pleased with that. Let me put the SD card ribbon cables back in and the LCD in and try it again. I think it's reassembled, just the battery. Nah. Battery plus USB. 160 milliamps. 180. Nah, it's dropped down to 1 again. Nah, I'm back to where I started. That was progress for a minute. Nah. Can't cop a break.